Okay, greetings in the love and light of the infinite creator. I am Andrii Zvorygin, joined here today with John Peach, Charlie, Dan, Ivor, Roger, and Peter. And we'll also have Jean Laherrère and Simon Michaux are planning to join us. Okay, so John, would you like to introduce yourself and share your presentation?
So I'm John Peach. I worked for about a decade actually in energy conservation, and then wound up turning myself into a mathematician. Spent the rest of my career at MIT doing research there. So I guess for the latter half, I didn't look directly at energy ideas, but I've kind of kept an eye on it. And so in, I guess it was 2018, Simon asked me to take a look at oil reserves, production, and I think you've probably all seen that famous growing gap plot. So I've been kind of keeping that alive and well ever since. And I'll show that and then show you what I've done since then. So I'm going to put this up and hopefully everybody can see this.
We're not seeing the share screen this time.
Yeah, hang on.
Okay.
Now?
There. Yes. Yes.
Okay. So this is kind of a broad look at the fossil fuel reserve. So not only oil, but gas and coal. And let me start by giving some acknowledgments. Simon was really the inspiration for this thing. He asked me to take a look at gas reserves. And then when I started doing that, I thought, well, why not throw in coal as well? We'll have all three of them. And then John Frost reviewed the paper initially and gave me some great feedback. The paper itself you can find on my website is wildpeaches.xyz, and the name is World Fossil Fuel Discoveries and Production. And all of the Python code is available on GitHub, so you can recreate this if you really wanted to. All right, so the outline, I want to look at what I think is really out there in terms of reserves, which will involve looking at the OPEC reserves anomaly. Then I'll look at an alternate method I've been using for estimating reserves. I think an important thing to look at is how Howard Odom's maximum power principle is playing into production values. Another thing that's critically important is why we need to backdate discoveries. I'll get into that a little bit. And then go into the remaining reserves of all three fossil fuels. And finally, I did it's essentially a logistic function fit to discovery data and a modification of that called a Richards function. So I'll explain all that. And I kind of stole this title from Jean, Charlie, and Roger, adding in gas and coal. How much do we have left is really the question that we're trying to answer here. So I found this
Good morning.
Recently. It was crude oil reserves. And I think this is sort of what most people kind of, if they think about it at all, this is sort of their view of the world. And as you can see, Venezuela has a lot of oil. Canada's big, Saudi's big. But to me, this is literally a very black and white picture. It doesn't capture the nuance of what's really going on. And one of the things that I want to point out is that both Venezuela and Canada, their reserves are very heavy, and it takes energy to extract energy. I'm sure most of you know that Charlie's idea of EROI, energy return on input or investment. tells you how much energy it takes to get this energy back out. And for Canada and Venezuela, it's quite low. I've seen some numbers as low as you get 4 units of energy back for each unit you put in, whereas more conventional oil is probably at least 20, right? Although
or 30, yeah.
So I think a lot
very complicated today, but 20 or 30 would be for a good field.
Right. And what I'm thinking is that without good diesel input, a lot of the Canadian and Venezuelan oil may wind up getting stranded. So I'm kind of writing them off, and I'm going to look at the more conventional oil. Okay, so let's start with looking at OPEC's, I call it reserve anomaly. They had a sudden surge in their reserve numbers in the 1980s. In fact, they, in some cases, nearly doubled their reported reserves. There has been talk that this was tied to quota revisions, that if they had a certain amount of reserves, they would be allowed to produce some fraction of that every year, and so that motivated them to suddenly find more oil. So it's very questionable whether they actually have this extra reserves. And the 2P, or proven plus probable estimates, are different from the quoted data, and so that's also leading to some skepticism. And of course, what this means is that there is not nearly as much producible oil as that first chart kind of showed. So let me show you this next chart. I actually made this quite a long time ago, but it shows what each country, OPEC country, claimed they had prior to the 1980s, and then suddenly there were these jumps.
Yeah.
And here I did a year-over-year comparison. So you see, in 1988, there were like 4 countries that suddenly found massive amounts. Saudi Arabia held off until 1990, and then they found a bunch. So if you take out this, you might get something a little bit better. So I called this the probable true reserves, but even this is questionable. And if you notice that up until the early 1990s, there was a little bit of wiggle in here, as if they were actually trying to do something, trying to give us decent numbers. But after that, they all went straight line. And so even that's kind of questionable. But so then this chart over here in the bottom right is what they claimed in blue, and then taking out those spikes in the 1980s, and this is more likely what they have, but even this may be optimistic. Okay, let's talk about discoveries, production, and reserves. So to me, the discoveries are what geologists said they found at the time of the initial discovery, using seismic imaging and core samples. And I think that this is fairly good data. Obviously, we're never going to know exactly how much oil is in the ground, but I think that's relatively good. Production, I also think, is relatively good, maybe even better than discoveries, because for every barrel of oil that is produced, it gets immediately sold. And so there are 2 parties to this. There's the producer and the buyer. And so they are agreeing on how much oil is to be delivered, how much money is to be exchanged. So I think in general, that's probably not too bad, although of course there are, hidden deals that are going on. And so we're probably not getting perfect data there either. reserves, I have always said, is the least likely to be valid data because it's based on current economic viability of the reserve and some estimated technology improvements. So I feel like that's the least likely to be good data. Now, Art Berman thinks otherwise. He thinks the reserve data is good. So we'll see.
The 1P.
Right, but this is
by
my
the SEC.
Sorry, go ahead.
The 1P by the SEC. You mean the reserve data, like that particular reserve data? Because I know there's other reserve data like Rystad, which is more in line with your
right. Yeah, no, yeah, it's sort of the generally accepted reserve numbers.
Yeah.
So for this reason, I think discovery and production data is the most likely. And so an alternative way of estimating reserves is to take discoveries minus production. So I take cumulative discoveries minus cumulative production and say, okay, this is what I think we have at the moment. Okay, so the next thing, we all know about Hubbert's peak, and it predicts that production is sort of a bell-shaped curve. It's symmetric about the rise and fall in production, and Hubbert used it very well to predict the peak of U.S. oil he said it would happen in 1970, and he was right on. Although, of course, there have been shale, which eclipsed that early 1970 peak. But the idea is that it will be sort of a bell-shaped curve, and if we extrapolate that to world production, we may be right about at peak right now, but that would mean that we have more than a century of declining production, but continued production if it was symmetric about right now. I'm taking a different view of this. I think that what's really happening in production is Howard Odom's maximum power principle that says that every energy system tries to maximize its total energy use. And this was, Odom was an ecologist, and I think Charlie's advisor, right?
Yes.
Yeah, so what this says is that we're going to continue to try to use as much energy as possible as a species until we hit some sort of physical limits and we just can't do it anymore. So let's take a look at the actual data. This is from Our World in Data, and I think this really does follow Odom's maximum power principle. You see that basically every source of energy is increasing. We just keep sort of finding every possible new source of energy. We throw it into the mix, and we keep going. So to me, this fits a lot better with Odom than it does with Hubbert. Okay, important point here is that we really need to backdate discovery data. And what this means is that you record the discoveries in the year that the oil field was found, and not if you update later and say, oh, there was more oil in this field than we originally thought. Let's count that at a later year. So, for example, suppose a big field was found in 1965. Let's say it was 20 billion barrels. And then in 1970, they said, oh, no, there's another 5 billion barrels in there. Backdating means that you go back and you say, okay, the discovery in 1965 was actually 25 billion barrels and not two separate discoveries. So it's more geologically accurate that oil was actually there all along. We just didn't maybe know that it was there. It improves the sort of the accounting of how much oil is really there. And it also eliminates this idea of constant reserve growth that I think is very kind of sketchy. It puts it more into the accounting, into the geology, and not into some kind of accounting. And I think what I found is that the U.S. Geological Survey does this backdating, and it's more, the oil companies and SEC want to see the not backdated data, but in reality, that oil was there all along. So I'm sticking with the backdated data. Okay, so here's the great growing gap chart that I've extended up until the present. And you can see that kind of the peak in discoveries other than Gawar was this field in eastern Siberia, Samatlar. Since then, since 1964, it's generally been downward discoveries, and we are way down now, down to 10 billion barrels a year or so in some cases. On the other hand, production kind of grew almost exponentially until the early 1970s, but then has been slightly greater than linear since then. What we see here is that since about 1980, there have only been a couple of years where discoveries exceeded production. So we're really drawing down the bank at this point. We're spending our capital faster than we're earning it. And in fact, at this point, we're producing about 10 times as much as we're discovering. So it's wow. Really going down fast. Okay, so again, let me point out that to me, this looks much more like an Odom model than it does Hubbert. And I think this is critical that we recognize this as more Odom. Mm-hmm. So looking at cumulative data, this the red curve here are the discoveries, and the blue is production. And so if these two are correct, then this green curve is how much it remains. So that's 678 gigabarrels of oil remains. One other thing that's kind of interesting is that the midpoint in production, that is the halfway point, was 1996, which means that since 1996, we produced half of all the oil ever produced. So this is, kind of surprising, I think, to a lot of people that it's very much front-loaded here. And if you want to think about this, climate scientists have been saying that, it takes about 30 years or so for the effects of fossil fuel burning to actually kind of work through the climate system. So we're not really seeing the full effects of what we've been doing over the last 30 years yet. I've presented this chart a couple times in the past. One thing that I found this year was that I get the production data from the Energy Institute, and it was a little bit lower this year than it's been in the past, which means that the reserve numbers are a bit higher, and that puts it closer to the Rystad estimates, which is kind of interesting. Okay, then for gas and coal, I found a database called the GoGet databases, Global Oil and Gas Extraction Tracker database. So I used that for the gas and coal, and was able to generate similar curves for these. And again, you see that the production midpoint happened in 2001. The reserves are heading down.
Looks
we don't have a whole lot left. Sorry, Andre?
It looks like it's heading down faster than the oil.
It could be. One thing, though, that I should point out is that the GoGet database was quite sparse. And so I had to go through a lot of work to kind of extrapolate or estimate missing data points.
Okay.
And so I think sort of in general, this is probably not terrible, but it's not going to be as good as the oil data.
Okay.
But even so, it says we have, continuing at the rate that we're producing it right now, we've probably got about 20 years remaining. And
Andrii, that actually makes a lot of sense. Talking with some of the folks down in Texas, to give you an example, I think Berkshire Hathaway and some other companies are backing up building power plants for the AI data centers. And the reason why is with the 2 new LNG export terminals we've got coming online, there's not going to be enough natural gas to build out the AI data centers in the next 5 years. So that makes perfect sense that the reserves of gas are dropping as fast as they are.
Okay.
Considering we brought LNG, turn that in, 5-10 years ago, natural gas in the United States was basically local inside the United States. Now it's an international market. So that makes a lot of sense.
And John, so this is all available in your GitHub, all the data points?
Yeah, all the data is there, all the code to do it, so you can go in and
great,
redo it all. I mean, it's a fairly large set of code there. So
awesome. I'll put the link in the video description after we're done here.
Okay, great.
Just email it to me.
Yeah,
great.
And here's coal. Coal is we've got quite a bit of coal left, almost a century of coal based on this, and at current rates. But it's gas and oil that are very limited, like 20 years. Okay, so one last thing that I did was I wanted to estimate how much we have left, and to do this, I fit a logistic function, or this variant called a Richards function, to discovery data. And so, as I said, production is probably pretty good. Discovery is based on geological science. That's probably pretty good. But reserve is more suspect. The nice thing about doing this logistic fit to discoveries is that it fits the this kind of S-shaped curve, and by fitting the function to this data, you immediately get the upper bound of the shape of this curve, or this curve, which tells you the upper bound on discoveries. Okay, and the reason that this is might be considered a good model is that in the early days of extracting a resource, things kind of go slowly. You're up against two things. You've got the technology that you've got to figure out how to extract that reserve, and you've got to sell it to customers, right? So not everybody's going to adopt it right away. But then once it does catch on, you get this very rapid increase in production, and then eventually you hit geologic limits, and there's nothing you can do about it. The derivative of this logistic function is the bell-shaped curve that Hubbert proposed, and I think that the discovery data does fit the Hubbert model, which is why I'm fitting it.
Okay.
And to show you this, I did this with all three fossil fuels, and you can see there's a very good fit here. I actually fit two separate logistic functions to this because I think that since about 2000, there have been a couple things happening. There's obviously the shale oil production, and I think there was a lot of money injected into producing oil, and so it fit better to have sort of a conventional oil period and maybe a fracking oil period, although it's happening at both ends. But what this says is that to date we've produced about 2,200 gigabarrels, and well, 2210 according to the data, and this model says that the maximum that we'll discover is 2228. Now,
Oh, okay. Mm-hmm.
I'm sure that somebody's going to push this hard, and so we'll probably go beyond this, but it means that there isn't a whole lot left to discover.
Yeah, that's half a year's worth.
Yeah. The same thing with gas. And I'm sorry, I have been using gigabarrels for oil in this presentation, but in the paper itself, I use exajoules for all three.
Okay.
But the important thing, I think, is to look at the shape of the curve rather than, actual numbers or units or something. Anyway, again, there's not a whole lot of gas left to discover using this model.
Mm-hmm.
And for coal, maybe a bit more. But of course, we have plenty of reserves left for coal. Okay, so in summary, I think that OPEC likely inflated their reserve numbers during the 1980s. I think discoveries fit the Hubbert model, while production fits the Odom maximum power principle model. And so I think we should be very careful about not trying to assume that we're going to have a symmetric production around the peak, the way Hubbert's model expects us to for world discovery or world oil production. And again, current discoveries are only about 10% of annual production, so we're really drawing down the bank very rapidly. We got oil and gas reserves only for about 20 years, and again, half of all fossil fuel consumption has happened in the last 30 years.
Wow.
And this logistic fit or Richards function fit shows that there's not a whole lot of discoveries left to be found. Okay, and just to follow up, here's my data sources, although everything, there's a lot more in the paper itself, and I can share that with Andrii and get it out there.
Cool. Thank you.
Yeah.
So, is there some questions from the panel? Okay, Roger? You got on mute, Roger. Okay, got to find that mute button. Okay, meanwhile, I have a question.
No, it's okay.
Oh, you have it? Okay, good.
Andrii, you go ahead first and I'll come in later. Go ahead, Andrii.
Oh, okay, all right. So, Jesper from YouTube says, our economic system appears to have trouble with shrinkage generally. Debts become unpayable. This probably affects the downslope. Any thoughts on this?
Yeah, it probably does, and I think that's a very important point, is that as the economy shrinks, that will have a large impact on future production. So the numbers could look worse than even what I've got.
Okay, thanks. Okay, Roger?
Yeah, thank you. Can you hear me, folks, fairly well?
Yes. Mm-hmm.
Brilliant. Okay. So first of all, John, a very good presentation. I'm very pleased to see it.
Thanks.
As you probably know, we, Charlie, Jean, I, others have been working, Richard Miller in this area, Michael Smith for years. So very pleased to see all this analysis. I've got about 4 questions and a couple of quick comments. The first question is your discovery data, the crucial, oil. I don't look at gas or coal, that's a separate issue. Oil. Your discovery data all come out of Global Energy Monitor, is that right?
No, the oil data is probably largely based on your paper, but then I've been keeping up from other sources, and I look at the Energy Institute data. So yeah, the Global Oil and Gas Extraction Tracker database, GOGET database, was useful for gas and coal, but because it's so sparse, I didn't want to do that with oil.
So hang on. Where your lovely plots of oil discovery, where do those data come from, please?
So it's various sources, but as I said, I pulled some of it from your paper. But yeah, I think it's all in the method section of mine, so you can see that. But well, and of course, a lot of data comes from the Energy Institute, which was formerly the BP data or statistical analysis that they produced every year.
No, that to be tricky, whatever. They don't have oil discovery data. They had reserves increasing every year, but they were standard.
Oh, maybe it was production. Yeah, you're right. If production data came from that.
Yeah, it's the discovery I'm interested in, because that's where it drives everything. So, where do you think that the oil discovery data has come from?
So there's that. There was Woods Mackenzie, and I've taken a number of different sources, so I wouldn't pin it on any one particular source. But if you have good discovery data, I'd love to have it.
Jean and I have been very lucky to have good discovery. John and I have been very lucky to have good discovery data, but only by having access to the very, very expensive data sets. And
I don't have that. I didn't want to spend any money on it. So if you can share it, that'd be great.
No.
So Roger, can you at least tell us if it looks like a good fit based on what you've seen?
The charts he's got, I mean, the charts of discovery, the crucial one is that oil cumulative, what he called the gap plot or whatever. Well, I'm not so sure about the 10% discovery now. I think the numbers are higher, but so I'd be a bit cautious about the current only 10%, but because we are putting in light tight oil and so on. But I love that plot, which just has global oil discovery cumulated over time, where, as you like to point out, one needs to point out, you can actually see Garwar in there. The nice little jump of Garwar is actually beautifully visible, as is one of the other big ones. But the crucial point is we've been plateauing. So I think the first thing is I should, John, send you the document we did called $1 million data sets. It's been updated because of some recent changes. The EIA, for instance, no longer publish the 1P, the numbers you quite correctly identify as incorrect numbers. So EIA has stopped it. BP stopped those some time ago. Energy Institute doesn't publish the 1P reserves data for good reasons. So if I can send you that $1 million data sets, that would be helpful.
That would be really great.
Okay.
$1 million too. You don't mind.
It's all caused by that bothersome Andrii man, because I used the phrase $1 million in a slang way once. So he asked Jean and I to do a presentation back a few months ago called $1 Million. But if you read it closely, the real data sets cost $100,000 a year.
But there's multiple.
You can buy on several data sets. Anyway, so let me quickly go through the last of my questions. Okay. So yes, I will send you. How do I get your email? Is that, Andrii, is that easy?
Yeah, I can give it to you.
Okay, so I'll send you the $1 million data sets. I do have an interesting $1 million. That's one. Yes, I do have one interesting comment. You're completely right on the shape of the curves, discovery, and all the rest of it for global. But if you dig down country by country, as Jean and I have done over decades, unfortunately, interesting enough, if it's a newer region like the UK, for instance, the discovery curve isn't logistic. It goes up very fast at the beginning as all those big new fields come in, 40s and all the rest of it. They come in very fast at the beginning and then tail off. So it tends to be up rapid. This is the cumulative, up rapidly and then tail off, rather than, as the global one showed, as we slowly learned what to do, up slowly and then rapidly.
Right, so that's why I actually use the Richards function instead of a strict logistic, is because you can shift the where the increase happens.
Yes, very good. I like that. And on production, again, looking at individual countries, I'm surprised how many, and Jean knows all this, how many countries do indeed follow a Hubbert curve, and the reason is not the Odom argument, but just so much oil is in those few big early fields. So as they decline, you bring in lots of later, smaller fields, but they're not enough. So that often leads to a surprisingly Hubbert type curve. And we love the fact that the UK's estimate of total oil in the UK North Sea, 4,500 million tons. The peak of UK oil was almost exactly when half of 4,500 was produced, and of course US and America was almost exactly half of the 200 or so billion barrels that America has. So an awful lot of places are surprisingly good, well matched by a Hubbert production thing, but just small points. But yes, I'll send you, I'm very pleased to see this. And so the last question, Andrii, you're being very tolerant. The last question is, why the devil we've been writing on this for 30 years. Colin Campbell and Jean have all this in their 1998 Scientific American paper. Why the devil are we discussing this? Charlie Hall knows. Why are we discussing this important stuff today and not 25 years ago, please? Any views, John? I don't know.
Yeah, there's so much that I just don't get why has not been discussed. I mean, it's some sort of psychology going on that, there's only a small handful of people willing to really look into this. And, of course, the vast majority of people are too busy to even think about it, right? They've got to go to work, feed the kids, whatever they're doing, to even begin to think about it, and don't even have the first clue about what's really happening. So,
yeah,
who knows? I just don't know, Roger. Just don't know.
All right, so we have some more.
One more thing that.
Thank you kindly. Very helpful. Thanks, John. Much appreciated.
Yeah. So, Roger, that other point about how individual fields, individual countries are symmetric, about using the Hubbert. I've also shown that it's entirely possible to sort of stack up where those production peaks happen, country by country, to get this very
Seneca Cliff
increasing production for world data, right? And so that's why I think we're seeing, you may very well see Hubbert model happening on individual fields or individual countries. But when you look at world data, we're pushing everything to the right, and that stacks up and looks very much like the Odom model.
John, I agree. Thank you. I agree with that. That's a very good point. Now, Andrii, I have one last, if you don't mind, then I'll let go.
Can we circle back?
Okay. Yeah.
Okay.
Yeah,
all right.
yeah.
Okay. Ivor. Oh, you're muted, Ivor.
Okay, I was just wondering about. Do you hear me?
Yeah.
About how much coal did you say was left in exajoules?
Well, I don't remember. There's like 27,000 exajoules or something, whatever the number was, but it was like a century's worth at current rate. So that's probably the more important data point.
Yeah. At current rates, yes.
Right. At current rates.
I actually have a related question from the YouTube. It says from Pascal says, once all oil becomes scarce enough, won't everyone just go to coal to liquids once oil reaches roughly 120 a barrel? Well, at that point, CTL becomes viable.
Yeah, who knows what's going to happen?
Mhm.
But the current economic system is so heavily dependent on oil that, you know, can we convert the coal to liquids fast enough? Who knows?
I'm also thinking that the at current rates is very important. Yeah, I think Dan had something to say on that. I don't know if you wanted to jump in there, Dan, or but based.
No, you're on target, Andrii, and that is at current rates. The other thing is remember, you know, we've got good examples of countries that have tried converting, you know, coal to liquids, like Germany during World War II, or South Africa did it for a good 30 some odd years. There's a good reason why a lot of these countries who have vast coal reserves basically figure out that the economics of it don't work very well.
Mm-hmm.
That yes, you can turn coal into fuels, but what is the price of that fuel? I mean, it'll be expensive enough where you won't want to drive. I mean, that's really what happens, is the costs go up to the point where I can't do that anymore. And either you adapt to something else, or your economy just plain slows down and simplifies. I mean, it's not really a choice.
Yeah, the ROI is so low.
Yeah, you lose at least 40 to 60% of the energy content,
At least.
and so you're having the ROI.
Well, it's just like, also there's a comment, somebody was talking about converting natural gas into fuels, and you had the same problem. 80% of your natural gas is consumed to produce 20% of a transportation fuel. I mean, the economics just are horrendous. You're trying to turn a gas into a liquid fuel. So it's the same issue. I mean, if it was a really solution, somebody would already be doing it, but we already know it's not. And that 100 years worth at certain consumption rates, if we switch to that, it wouldn't be 100 years. It'd probably be 20 or 30 years. It'd go really quick.
Mm-hmm. Charlie, you had a question? And then Simon. Charlie, I don't know if you're still with us. Okay, let's go over to Simon. Maybe Charlie will come back later.
Hello.
Yeah.
Can you hear me okay?
Yeah, go ahead, Simon.
Yes, I'm okay.
So, do you want to go, Charlie?
Sure, sure.
Okay.
I'm traveling, so I can't send you this now. Please send me John Peach's email. Your assessment, I think, is excellent, and the interesting thing for me is that I have a graph that's essentially the same that I published in the Bulletin of the Atomic Scientists in 1975. And I want to address the question of why are we not discussing it now? And as I've been through many cycles of people caring and not caring about how much oil we have, the basic answer is, to whether people are paying attention to it or not, is the price of gasoline at the pump, which is low at the moment in inflation adjusted terms. Not real low, but low enough. And fracking has saved the world's ass, and especially the United States' ass, because without that, fracking now is producing about 80 to 90% of our oil, and also natural gas. Without fracking, we would be really up that shit creek, and without a paddle. And so whether people pay attention to us totally depends, I think, on the price of gasoline at the pump. And that's why nobody pays any attention to us, because they think we're crying wolf. And so I don't know how to get around that in the public perception. John Peach, if your numbers or our numbers are approximately correct, we'll have another few years to a decade of cheap oil, and then things will be, I think, an awful lot tighter. And I think we'll go after all of these low ERI fuels you were discussing because people will be desperate. And then what? We'll all be dead. So that's just the way that I look at it. And good job, John. I do have one thing though, is I think there's going to be a long, expensive tail.
Mm-hmm.
And I'm glad to see you give some attention to to Odom's maximum power. So I think it's a very powerful concept. And everywhere I look, sure seems to me it's not that everybody is following the maximum power curve, but it's what Odom said way back in the day, again and again to us graduate students, was if we don't burn that oil, somebody else will.
Right.
And if we don't burn, right now, China is building, not counting the ones they have built, they're building 48 nuclear reactors, many square miles of photovoltaics. They have, I carry a sign in our local anti-Trump parades. I'm extraordinarily anti-Trump. It says, "Make America great again," and destroy our universities, destroy our science, destroy our alliances. And, I have 8 things that destroy our healthcare, which is what he's doing. He's destroying our country in the name of Make America Great. He's destroying all the institutions. So I think China will be burning that oil. And I think we have to recognize that. And I have another picture showing people paying attention with a cameraman and a guy pointing it out of a small wave on a beach that's called, I label CO2. And there's a much larger wave that they can't see that's breaking over them that says depletion.
Yeah.
And depletion, I think, is not just depletion of the source, but depletion of high EROI fuels. So, John, I think you're right on, but there's more nuances to that about, I think we're going to be developing as Canada is some of that heavy stuff. And we'll have probably a long, expensive tail full of wars for the good stuff that's left. That would be my best guess.
Yeah.
Okay.
Yeah. I recognize that there was a lot more detail that I haven't gotten into. Even things like.
Well, John, I'd like to see what you're doing. The problem is we don't have funding. I haven't had. I've been funded millions of dollars for doing crappy research, and no money for doing oil research. And despite many decades of trying, that this is not funded, and it's not vetted. The data is not vetted. It's in global institutional failure on a massive scale. The most important things facing all the civilized so-called countries, and they're not funding any research on it, and they're not maintaining the standards of reporting.
Right.
Those jumps you talked about are just criminal and never been checked.
Yeah.
I think.
And Rystad's data, we need to vet that too. We have to have Jean Laherrère look at everybody's numbers.
I just wanted to add a few points of clarification. One is that there are people watching. There's like 30 live people, and then you get thousands of views for every of these live streams. And it does seem to make a policy impact. Also, China is the largest fossil fuel consumer. And I think in the world. And so you're right. Someone will use it, and that someone is China right now. And another thing is that I think that part of the reason they're not looking into this is because they're scared. They're scared to look. China stopped doing its coal reserves updates. They're just like, we're just going to go full tilt. We're not going to look at what's left. So yeah. Okay. So next was Simon.
All right, can I make a quick comment on the coal?
Okay.
So I started my career during the Arab oil embargoes trying to look at replacing oil with coal and how, where and how it could be done. And there are two practical things about it. Number one, it's filthy. We can look like some of the China and Indian cities as we do that. So it becomes more expensive. But the other thing, when I was a kid, we shoveled coal into our home boilers, right? They're all gone. They're not available. You cannot get them. So if I wanted to replace my gas furnace with a coal furnace, I can't. I can replace it with wood, but not with coal. And all of the coal facilities have been shut down, and getting one back, you know, compared to an oil and gas facility for power production, coal is longer to do, much more expensive on the electrical production side. And we've just taken them all down. We're a bit like Germany stupidly taking down its nuclear reactors, you know, just stupid decisions. But once we've made them, trying to get them back, you know, the EORI shouldn't be just, I think, on mining the coal. I think it should be also on what it would cost to rebuild a coal-fired power station to use it, which makes our EORI on coal just unbelievably pathetic.
So you're Barbara?
I'm Barbara.
Yeah. Okay. All right. Thank you. Okay.
Oh yeah, I didn't put a name in. I've been driving across northern Illinois, so I've been kind of lurking. But I had to make a comment.
I can answer some of her questions, Andrew.
Oh.
What she stated.
Oh, what was it? Oh, you had a direct comment on that?
Well,
I just
wanted to ask her a question. So understand, I'm sitting on about 30 coal-fired power plants here in Indiana. So the reason why we back away from coal has to do with the quality of the fuel. The high quality coal, the anthracite that you probably remember when you were a kid, it's gone. The coal we burn right now is called bitumen, and it's between 40 to 80% carbon content. And basically, the point is you've got these high ash coals that also are high in mercury, cadmium, and radioactive material. And that's the reason why we're shutting down the coal-fired power plants. It really has to do with the quality of the coal. When you're burning a fuel where most of it is waste material rather than energy producing, the cost of removing the waste material basically exceeds the benefit of the electricity that you're producing. So even if we try to go back to coal, we have a lot of low quality coal that doesn't produce much energy.
Okay, thank you. That's very valuable information. Okay, now hopefully Simon will have a chance. No?
Right, guys? Jesus. All right. To ask, I actually have information. To answer the question, why is it we still have to talk about this? I actually got an answer. Now, I presented at a couple of conferences now. The combination I'm currently using is a combination of Art Berman's work and your work, John. And that combination is lethal. We won't have time to present it tonight, but I can present it next time if you like. It's your information mixed with art. Anyway, so what I actually... why is it we are still having this conversation? The information I've been presenting is decades old in some contexts. So why are people still acting surprised? So there's a couple of things that are happening here. Number one, there is this taboo-like feeling to discuss oil. They actually said it out loud this time. We must not talk about oil. There is a sensitivity associated with it. There was one lady I was talking to in the crowd over coffee. She used the word evil. She says fossil fuels are evil. Fossil fuels are the enemy. don't talk about fossil fuels. We've got to get past them. We've got to get rid of them. Don't put any energy into them. Walk towards the future, not towards the past. The second thing that is happening, this is people's perception. The second thing that's happening is fossil fuels is in everything. To the point where you can't even see it anymore. It's like oxygen. We breathe oxygen.
Mm-hmm.
Right? Do we talk about it? No, we don't even see it. Fossil fuels is a bit like that. So the combination of those two paradigms together have created this narrative of the green transition is a done deal. Fossil fuels are going. We know how to get rid of them. The technology is ready. We've been talking about it for 25 years. It's all good. Let's go. Right. The practicalities are not looked at because they don't seem to sort of think in those terms. Right. And the priorities are so strong in that, not to talk about fossil fuels, but we know what the plan is. The priority, which is taking up most of the bandwidth, is about how we do it. For example, DEI and gender equality. Right, that is the actual focus. I was in an energy sustainability conference recently, and most of what they wanted to talk about in that energy sustainability conference was human rights and gender equality. And so that to me, that was their solution. When I actually asked them, how does this stuff, this is all laudable, but how does this actually influence the generation of electricity? They couldn't answer me. So there's a series of narratives, and I think this is a programming level where we become our own sheepdog. We regulate ourselves and we regulate each other. No one tells us to do it. We've been programmed to do it. So that's what I believe is happening. So all this time, we believe it's a done deal. We won't look at fossil fuels. It's taboo. It is psychological. It is belief-based. So I've heard a few people on this call talk about that. That's my perception now. I've seen it quite a few times, and now that I understand that, I know what to say to actually bring that programming out. I actually had a moderator actually cut me off and say, look, okay, we don't need to talk about oil. No, there's a bit of a sensitivity there. Let's move along. Mm-hmm. Really? So that's what's going on. And while that is the case, we're going to go round and round and round until something breaks. Anyway, that was
okay. All right. Thank you. So, yeah, we do want to get to your presentation as well. But I see Roger and Dusty have questions. If we could do that within the next 5 to 10 so that Simon has a chance as well. Roger, go ahead.
Very quickly, I'm a bit more optimistic than most of you. There is a lot of kerogen. You're right about coal and stuff, and we've got to sequester the CO2, but Hubbert came in on the back, keen on nuclear, and then when he looked at solar, he decided there's a lot of solar. So, and I've worked in solar for many years. So, I using the phrase from Michael Smith, I think there's a reasonable chance we'll muddle through, but it is going to be a muddle and pretty difficult, and probably some of those wars that Charlie reckons. Okay, thanks, folks.
All right, and Dusty. Dusty, are you ready?
Yeah.
Okay, go ahead.
So yeah, I wanted to discuss that same topic of why is this so taboo to discuss, and I think there's a few different things that go on. I think one, does seem to be some narrative control going on, because you can search online, on X, on different platforms, and the general topic of energy scarcity is just not there. And I've encountered, I worked for a YouTube channel that was in the space of energy for years. And so I encountered also what people have mentioned of this sort of, oh, don't talk about this. This is taboo. I've experienced that firsthand also. And on the other side, I've also experienced on the pro-oil side, on the right, people being very into the biogenic theories, and there's no limits. So either way, it's kind of, you're stuck in the middle, and everybody hates the person on the fence. So you end up getting hated by both sides when you discuss this topic. But one thing that might be an idea that we can come up with, and this is kind of like what Charlie mentioned about the price at the pump. How can we get people to discuss this topic? And I think it might end up being through imagination. So since the oil drum and other times, we've had a lot of effort put into the intellectual side, and we need to continue that. But I think we're lacking majorly in the imagination side. And how can we get people to think, what would my life be like if the price at the pump was 4 times as much? What would my life be like if we were facing a 1970s, oil shortage type experience, And I think if we can help people imagine what is looming in the 2030s, and maybe we have a chance at getting this discussion to come up again.
Yeah. Good points. Dan, I see.
Yeah, there is an answer to what you're saying, Dusty. This energy topic is going to be on everybody's list 12 months from now, and the ground zero is going to be the state of California, because they're shutting down the Phillips 66 there in LA, shutting down as we speak. They had a major fire there at the Chevron refinery, and of course Valero, they're going through with their shutdown, with taking out the one there in Benicia. So this is going to be a number one topic, especially in California, and therefore it's going to be a topic for the entire nation. So my point is, the other is, when you talk about the price of fuel and so forth, understand the solution to low prices is low prices. Low prices cause less production. I also know that just looking at just the banking of the shale complex, if we hit $50 oil and you sustain it for 3 months, that'll bankrupt the shale complex. And the big majors like Diamondback and Exxon and so forth, they have no incentive to go out there and drill any more shale. Mostly whatever shale is being produced right now is a lot of the independents that are still hanging on as we speak. So a lot of this is going to solve itself, is what I'm trying to tell you.
Thank you. That's interesting about California.
Everybody keeps forgetting about that. That's not an if, that's a fact. It's going to impact. This spring it'll hit, and then by the fall, everybody in the nation, probably the planet, will be talking about this.
Prices will go up, I'm assuming you're saying.
Oh, because that refinery is closing.
The South Koreans aren't going to give away their diesel and gasoline for free. Sorry, they're not.
Oh, okay.
Maybe, Andrii, what we can do is all put our heads together and try to come up with a fictional story or a documentary that we can have Simon do the voiceover for.
That would be interesting. Yeah, Simon will get us the views. All right, Charlie. Okay,
I love what Gustav Mahler said, who's noted as a great conductor in his life, but not for his symphonies. I'd love to conduct my symphonies in 50 years. And then Leonard Bernstein came along and did conduct his symphonies in 50 years, and they both became famous. So I'd love to give my lectures in 50 years.
Okay, cool. All right, so I know Simon and Jean also has an update for us.
Okay.
But I guess
so
start with Simon. Go ahead.
All right. So what I'm presenting today is a quick tour through the Limits to Growth study. I've been challenged on one of my talks in the comments section, where someone thinks I'm full of shit about what in particular about the population simulations of what the Limits to Growth project actually showed. So let me just try a screen share. Okay. So I'm going to talk about quickly. I'm not going to present everything. I'm going to rocket through it. What the 1972 Limits to Growth report actually was, the World Food Model. A data update to the year 2000, I overlaying the data over that. A review of the Earth for All. Now, this one's a little bit uncomfortable for me. It turns out that Earth for All model was fraudulent. I'm going to present someone else's work on that paper. And then finally, the current evolution of what the World 7 is. Like 1972 Limits to Growth was based on World 3. World 7 is the current model. All right, let's get underway. Limits to Growth, this is the report that we actually have all been referenced since 1972. It has a series, it's a systems-based model, and it does a series of calculations like this. For example, population, you've got births per year and deaths per year. You've got mortality and fertility. And so then you've got the actual simulation that goes through what is population. Then you've got a series of other things like industrial capital or agricultural capital and what have you. The whole system looks something like that. That's the World 3 model. It's actually quite sophisticated considering how far back it was.
Mm-hmm.
The outcomes were as follows. They did 13 studies. The first one was what's called the standard run. That is, how will things go if we did nothing? How will things proceed between 1900 and 2100? They don't give a date of prediction for crash. They just predict a series of trends. How the media has actually presented this over the years has been a little bit dodgy. So here we have sweet. Okay, so here we have population is the solid line. That's it there. Population rises and falls. Resources, they're non-renewable resources, and so they're depleted. We have pollution, food per capita. We've got crude birth rate, crude death rate, services per capita, and pollution.
Mm-hmm.
That's if we do nothing. So then there were 12 more simulations where they tried a few things. This was to try and test what would actually happen if we tried a few things. If we had a model, the same model, but we had natural reserves doubled. So these natural resources, if we had doubled the amount, well, and still in the same time frame, food per capita peaks, and then you've got industrial capacity peaks, and then later population peaks. What does happen? What's that dotted line there?
That's the pollution.
Yeah, okay, pollution goes through the roof. Yeah, so we've still got a crash in population. The next one was a model with unlimited resources. If we had unlimited resources, what would happen? Well, there's our resources. Pollution goes through the roof. Food per capita still peaks. The population still peaks and declines.
Wow. Well, because the pollution kills everybody.
So, so this is a very simplistic model you have to remember.
Mm-hmm.
The world model with unlimited resources and pollution controls. Now we're going to, there's the pollution. We do something to actually stop the pollution from happening. So
Okay.
population still peaks and crashes. It's later, but it still peaks and crashes. So now the next one was a model with unlimited resources, pollution controls, and increased agricultural productivity. So pollution controls, even though pollution controls, it still goes through the roof. Resources are still declining, but they don't go to zero. Population still peaks and declines.
Mm-hmm.
World model with unlimited resources, pollution controls, and perfect birth control.
Wow.
Okay, so perfect birth control. We've still got a peak in population. There it is. Unlimited resources, pollution controls, increased agricultural productivity, and perfect birth control. Look at this pollution line. It goes up, goes down, but then it shoots through the roof.
Oh, man.
And the population does reach a peak. It stabilizes, but it does go down again. We still get a crash. So basically, they came to the conclusion was a population crash could not be avoided. It could be deferred, but it could not be avoided outright. Next thing was, well, what happens if they stabilize population? If births and deaths became the same thing? So population now stabilizes. So food per capita still goes up and then it goes down. So we've still got problems here. What happens to food?
Mm-hmm.
So
it's because resources.
Yeah.
Mm-hmm.
Everything's connected. Yeah. What about if we had stabilized population and capital, industrial capital? So there's population and there's industrial capital. So we still get food per capita peaking and then declining. So it's, again, you've got to solve multiple problems at once. You've got it right. So stabilized model 1, where population and per capita and everything else is actually forced into line. Technological policies are added to growth regulating policies to previous run to produce an equilibrium state far in the future, and so on. And so resources are still declining, but they're declining less. Stabilized model 2, if restrictions in growth in the previous run are removed and population and capital are regulated with natural delays in the system. So population does stabilize and stay there because it's forced to stabilize there. Industrial capital does actually sort of come up. Population has to be stabilized, but everything else has to be stabilized as well. So the world model was stabilizing policies introduced in the year 2000, which would be in the middle here. So the policies instituted in 1975 in the previous year are delayed until the year 2000. The equilibrium state is no longer sustainable. Population and industrial capital reach level highs enough to create food and resources shortages before the 2100. Right, so we still have a problem, is what that's saying. So here's the data update. Now, this is my friend Graham Turner. He wrote a paper in 2008 where they actually took data from 1970 to the year 2000, and that's actually the dot here, and that's the observable data. The standard run, which is the first one I showed you, is the green, and we're right on the standard run. They have this, this is one that's come from, I don't know where this has come from, but a comprehensive technological revolution of some sort, where I think it might be the digital revolution that was actually underway at the time. But even so, we are very much online with the standard run. Now, the Limits for Growth report has proven to be conceptually correct, but it's of limited use. I want to say that this is based on a fossil fuels world. What happens if fossil fuels is taken away? This model collapses. As in, when fossil fuel starts to decline, is no longer available to run everything, this model is no longer valid. The second thing is industrial capital. Money in particular is funny money. It's subject to hyperinflation. When that happens, I think this model also won't, the industrial capital line won't work very well. The other thing is we've now got a steep decline in fertility rate. Some of the health problems associated with COVID vaccine in particular, that's my thing. It's not everyone's cup of tea, I understand. But if that is real, that the population model also won't work. So those three things together tell me that the Limits to Growth model is of limited use, and our prognosis for the future is actually more difficult than what this suggests.
Than the standard model.
Yeah. Mm-hmm. So the standard model, if we go back to it, is that one.
Mm-hmm.
And we're on track for that. But what happens when peak oil hits?
Mm-hmm.
So our food production, our industrial per capita, all of that, so our ability to access resources, all of that becomes a whole lot harder.
Mm-hmm. Yeah.
Right. So now what? All right. So the next. So this is Earth for All. It was an evolution of the Limits to Growth model. This is rather uncomfortable for me. I really liked this report when it first came out.
Mm-hmm.
So what they did is they remodeled it. They took the World 3 and they actually sort of developed a new model. Two basic scenarios. One is the standard run, as in what's happening there, and the other is the giant leap. The giant leap is if we do these 5 things: empowerment, gender empowerment, inequality, energy, food, and poverty. And somehow all of those resource problems that we were talking about before get fixed up. This is actually sort of related to what I was also saying is trying to talk about sustainable energy has somehow been forced into the DEI and human rights frontier. Now, this is the report. Gaia Harrington did a podcast. Has done a couple of podcasts. I really liked how this model was presented. So what I'm about to present you now, this is not very comfortable for me. And if someone can disprove what I'm about to show you, I'd be very interested in having a look at what that is. If they could disprove it in something beyond I'm offended, that would be good.
Mm-hmm.
All right. So why is that not? Okay. So what I'm now going to show you is a paper that actually a colleague of mine called Harold Sverdrup has actually, entire screen, share. Okay. Earth for All Systems Dynamics Model. So the authors are these people here. Christian Ragnarsdottir, they're Norwegian. Harold Sverdrup is actually my friend and colleague who's actually my contact with all this, Professor of System Dynamics. Hoda Haraldsson and Bridget Komansky. They're all professors of systems dynamics. What they did was they downloaded the Earth for All model from the Earth for All website. They looked at it in both the VenSim model version and the VenSim version opened in their Stellar software. And numerous test runs show what I'm about to show you. Okay, so here's the actual paper. Now this is, it's under review. It's been handed to a few journals, but the journals so far have said, oh, no, we don't want responsibility of publishing this. There's another attempt to sort of get it out. I've read through this, it holds up. Okay, so there are many aspects of the model that are partly discussed that are not peer-reviewed but are available online. Several aspects are discussed in the book and not included in the Earth for All model. They observe that the 5 transitions and policy outcomes described in the book are not supported by the E4A model. The 5 transitions have no representation of the model at all. It's not a proper dynamic model based on causal connections, feedbacks, and mass balances, but rather a set of command and control functions, forcing preset outputs as a responsive and assumed policy. The population module in E4A has some serious flaws and fails to make realistic scenarios. The food and agricultural model lacks basic components such as food supply and does not constitute a valid agricultural model. There is no economic model, and the labour market module yields more employed people than working age population and is not mass balance consistent with the population model. There's no natural resources of Earth for All of any kind. Okay, so this is the actual paper. They did a series of studies. They looked at this. The key questions to address: does the required and does the model have the required necessary parts of a system represented in the model? Does the model have causal feedback structure representative of the system it is meant to represent? Are key policies and the systems they involve represent in the model? For internal consistency, is it clearly shown in a causal loop diagram and flowcharts in the background documentation? Is the model mass balance and energy mass balance consistent? And so on. Validity. Has the model performance being tested in an observed independent data for the past, and for that data not be used in calibration? Is the model consistent with earlier research in the field? Right, so these are the questions they went in, and they did a series of, so this is what they mean by a forcing function. A system of preset forcing functions to make outputs redundant to the inputs. So they want an output, they'll put a forcing function to get the output.
Oh.
Yeah, I'm afraid so. So let me get down to this. When they're actually running it through their software, this is the error they would often. The model cannot be run because of errors and so on. It won't even compile, right? And so there's all these problems along the way. Okay, so this is a lot of jargon. It's not necessary for everyone. So when we get down to the actual conclusions.
It seems like it was basically a propaganda piece.
Look at that. That upsets me.
Oh, sorry.
No. Of course, you can say that, but it pisses me off. It was I liked this. I like this idea. This really does not. Yes, it does seem to be a propaganda. No, I'm not criticizing Andrii. Right. Assessment. The model and content. Does the model have the required necessary parts of the system? No. A significant part of the necessary required parts are totally absent. Does the model have causal feedback structure representative of the system it was meant to represent? No. It is controlled by forcing the outputs. and a causal feedback structure is largely missing. Much of what there is here is faulty or outright wrong. Are the policies in the system represented? No, they are missing in their entirety. And so on. Right, conclusions. Okay, for the 5 turnarounds, Earth for All and how it was handled in the E4A model, poverty is solved by handouts and printing of money without limit. Inequality is done by forcing functions towards a commanded end result. Empowerment of women is not on the E4 model, as in there are people in the model as population, but the model itself doesn't distinguish between men and women, let alone how they might change their behavior. Food and agriculture are done with an invalid model of agriculture in the E4A model and a lack of food supply chain and loss terms in the way it is not mass balance consistent. There's no valid food and agricultural module at all. Climate change is done by linear scaling and forcing functions. There is no carbon balance. Energy is done by creating renewable energy without any metal or material limits. There are no energy balances anywhere in the modeling. Okay, we observe that. The authors observe the 5 transitions and policy outcomes described in the book are not supported by the model. The 5 transitions have no representation of the model. E4A is not a proper dynamic model based on causal connections. The population model has some serious flaws and fails to make realistic scenarios. This is actually what I read before. Okay, and then there's the actual citing. So, so let me come back. This is the Earth for All model was actually sort of released. I think the Club of Rome supported it and everything like that. And a lot of organizations around the world are now supporting this is what we should be doing. That's not just a little bit wrong. That is seriously flawed. I are pissed. Right. So anyway, last. Okay, before we move on, there's a third thing I'm going to do. Before we do that, do you want to discuss it? There's a few hands up. Dusty, hit me. Actually, who was first? Andrii.
Yeah, Dusty was first.
Hit me, Ant.
Okay, so the question here is for a dummy, right? Okay, so how can you simplify this in the sense of, was this a philosophical plan, but it's presented as it's a data-based model, and that really wasn't there? That's the first question. And the second question is, can those guys that wrote this paper, can they fix the model and make it accurate, or can someone use AI to fix the model and make it accurate? And if so, the third question is the outcome politically inconvenient? Okay,
we're actually touching on all 3. The first, what I believe is happening is this is an ideology. This was an ideology where someone actually went in there and saying, we want to actually show that if we think and do things in a certain way, we get the outcome that solves all our problems. Right, we have some very serious structural problems for our society and civilization going forward. What have we done about that? We have largely ignored them. What have we done instead? We're chewing up our intellectual capital on things that are of peripheral, where we get our energy from and how we generate our electricity does not interact with gender equality in the workforce. If someone can refute that, I'll be very interested for them to actually sort of show me how that is the case. So this is an ideology that has actually sort of come in. They wanted to actually force an outcome. And so I believe this was a public relations stunt, if you will, which is then being used to great effect, saying we've done a simulation in numbers. That's how it appears to me. Now, I'm not the author of this, but the author, Harold Sverdrup, is a colleague of mine. I've worked with him for a couple of years now. His personal integrity is very good, and he is a world-class simulation analyst. And I've looked at his data, I looked at his simulations, I read the paper, I've spoken to him about it. This is holding water. So the second question, what was the second question again, Dusty?
Can those guys, maybe using AI, or just it sounds like they're qualified,
can we fix it? Right,
fix
no.
The model?
Yeah,
can they
the
fix
answer is
the
no.
model? And then the third question is, if they do so, is the outcome actually possibly a negative outcome? And
I believe that the attempts to try and salvage this with a bit of surgery failed. But what Harold has done, in fact, what his colleagues have done, is they've gone and built a new system from scratch, which I'm about to show you.
Oh, nice.
Right now, but this and it is World 7 is publicly available, but the Earth for All documentation when it came out, that has been used to great effect. I see it everywhere. All is well, stay at your posts, your government's got it under control. Use your credit card. You stupid motherfuckers.
Well, they might know what they're doing.
I'd be very curious to see, though, if they were able to. I'm very curious to see what this other model they made is, but if they were able to repair the errors in that model, just to see what the outcome is.
The problems is the structurally fundamental things are missing. It's not like certain things needed to be tweaked or new parameters. Structural things were missing. Like how can you have a food model without food supply? One of the primary outcomes of, for example, inequality in the workplace produced more workers than population. These are not small errors. It's not a question, and so I think there was an attempt to fix it, but it didn't go well.
All right.
And the answer is yes, it's politically inconvenient.
Okay.
Very inconvenient.
Did you want questions from Roger and Charlie before we go on?
Let's do this, and we can move on to the third part.
Okay, sure. Oh, okay. So the questions first?
Yeah, look, there's questions about this. They're everywhere. And people want to answer.
Okay, Roger, go ahead. You got on Roger. Oh.
Just move your mouse, Roger.
Right. Very pleased to see this. I'm pleased you're going to talk about the Sverdrup and Ranglen-Stottir real model, because to be honest, I didn't know about Earth for All, but I know about the Sverdrup, later the model, the World 7 and so on. So I didn't know about the other one. I thought the World 7 was the main one. You will also know, without the book, you will also know this one.
Yep.
2052, where he says it's not even a scenario, it's actually a model. He's very keen on that one. And so the last thing, I shouldn't take your time, but the last thing is a nice little footnote, which is quite important. The 1972 limits to growth indeed had non-renewable resources, 100 years worth, which of course was clearly going to run out fairly quickly. In the update, whatever the year was, the first update, they put in the correct number for the amount of oil. The URR for oil was correct, but they didn't know about peak at midpoint. There's a nice little bit of history. So had they known about peak at midpoint, they would have had a slightly different picture in their update when they put the correct URR for oil in. But I'm very pleased you're going to talk about this further up World 7. Thank you.
All right. And well, just to clarify, the midpoint for oil extraction, John Peach was saying was in the 90s, right? But so that wasn't the peak of production, though.
The peak of discovery.
Sorry. Oh, peak of discovery. Okay.
Sorry. The midpoint of production. You're right. To date, happened in the 1990s, and I don't think that we're going to see a world scenario where it's symmetric about the peak.
Mm-hmm. Okay, Charlie, you had a question for Simon?
Yes, Simon, I think when you're evaluating the original limits to growth, you have to have two things. You have to stabilize the population, and you have to stabilize investment. I'm traveling. I can't keep up with everything you're saying.
Yeah.
But that was a very important thing that they had to have to get a stable model. Now, the second thing I want to say is that you've written to me, and I'll reply to you in a few days about Sverdrup and where can we publish it and so forth. So I'm not ignoring you. And that was the main point that I wanted to make. And to have a model where you're not including the energy costs of the renewables, especially of dealing with the intermittency, etc., makes no sense at all.
Yeah, exactly. That
So
was the conclusion.
I agree with you, and I can't believe Sertup. I thought Sertup was smarter than to
No,
do.
no, no. You misunderstand. So, no, Charlie, you misunderstand. What I just presented you for Earth for All was not Sverdrup, right? Earth for
Oh,
All was actually the Club of Rome, Gaia Heritage. Sverdrup went in and reviewed it, and so what I just showed you was Sverdrup's work.
oh, his criticisms. Okay,
Yep.
Yes.
He
all right.
set
Yeah,
fire
yeah,
to it.
yeah.
He burned it to the ground.
Hmm.
Who? This is published version 7.
Version 7, which I'm about to present, has already been published. Yes.
And has these glaring problems.
So
I mean,
no,
it's a problem with people who think of the world in terms of social science and
I'm
natural
about
science, it seems
I'm
to me.
about to present a third presentation that showcases
Okay.
World 7, and
Okay.
it accounts for things properly, or at least much better than anything else I've seen before.
Okay, thank you for clarifying that.
Okay. So last one, Ivor, did you have a question for Simon?
Yeah, I just did a little back of the envelope math, and for the original presentation is we only have about 18.8 years left of oil.
17.7.
How many?
17.7. John, your work is excellent. Your work has been shouted from the rooftops all over the world.
Yeah.
And yes, I actually presented that before the United Nations, and the whole room, their sphincter contracted. When you actually take John's final gigabarrels of oil that's left at the end of that green line, and you divide that by last year's 2024 oil consumption, which is 32.7 gigabarrels, you get 17.7 years. Oh my stars and garters.
Right. All right. Okay. So I think Simon.
And the consumption rate is climbing, by the way.
Yep.
Yeah.
What could possibly go wrong?
Yep.
All right, Simon. So you can do the World 7 now.
All right, let's kick this on. Okay, entire screen. Roger Bentley wants to speak before we kick in.
Okay.
Yeah, you can hear me, folks?
Yep.
Yes,
I simply have to kick in. I support 90% of what everybody's doing, but for crying out loud, when you're quoting your 17 years of what's left, just go on the globalshift.co.uk website and look at their forecast for the future. It's built from bottom up. It's got all the right data. It's industrial data. It's $100,000 data sets. Just look at that. And it's grim, I know. The world peaks in 2040 or something, or 2035, but it goes down, and it goes down slowly. So, it's not the end of the world, you folks. I don't think any of you are thinking that, but there's lots of oil, and we're going to take a long time to use it. Just goes down slowly. So look at the globalshift.co.uk website, please.
I use this work, Roger, not to get people's hair on fire and to get people to run screaming from the building. What I'm trying to do is get some intelligent conversation of what do we actually do with the oil that we have left. And I'm with the understanding we've got decades of operation.
Okay. Thanks. Yeah. Thanks.
Right. And this is my purple transition.
Throw in there with Simon, everybody needs to understand that as the prices climb, the consumption rate will fall. Like, we'll be forced into coming up with some kind of a solution. We won't have a choice. The prices will tell us, and that'll actually drag the consumption out for a very long time.
And I just want to add that, we're talking about oil, which is fueling many other things, but humans need food. And this is something a lot of people don't really get. But yeah, humans do need food. And in Canada, at least, I was doing the projection. It's already a quarter of people are food insecure. And by, 2030, it'll be like something 35%. And then by the mid 2030s, we're going to exceed 40% at current trends, and that's historically that usually leads to a regime change or a collapse. So we'll see what happens. Anyway, Simon, go ahead.
All right, let's kick on.
Okay, we see, yes. It's full screen.
May I present World 7? This is the work of Harold Sverdrup. Harold, if you're listening, your work is excellent and I do appreciate it. World 7, the road to linking natural resources, population, energy, commodities, services, economy, health, governance, society, and harsh language. All right, the purpose of the model: develop a tool to understand the world, link natural resources and everything I just talked about, remake the economic models into something that's reality connected, feedback on physical and monetary dynamics, model the interconnected world as it could be under sustainability, explain the past, validate the model capabilities, link knowledge, and test paradigms. This is game theory. And this is something that I've only recently come to understand in the last couple of years. It's powerful. This could well be one of the most important tools to navigate our way out of this. Right, evolution. So World 7 didn't just happen in a vacuum. World 1 and 2 were developed from 1961 to 71 by the original Limits to Growth team. World 3 was the evolution of their work, and they published their report in 1972, and they worked on it till 2004. This is Donna Meadows, Dennis Meadows. So this was actually sort of really, amazing work. World 7 is the current outcome. World 4, 5, and 6 were developed by this team. That's Harold there. In what's called the Stellar Systems Dynamics software. 2011 they started, so World 4 and in 2019 World 7, which I'm about to show you, a global integrated assessment model, reorganization of the whole model structure, completion of the resource parts, emphasis on the whole system, cross-linked feedbacks. Okay, the basic underlying model is this. So you've got economic and finances, food systems dynamics, population and demography. You've got materials, metals, and fossil fuels. You've got industrial dynamics and energy production, and there's the causal links between them. That's what the model looks like when you put it all together. It's complicated. Mm-hmm. There's metals and materials, industrial dynamics, economy, environment, energy. There's the energy sector there. Society, food and demography, health, and people. So this is natural resources, metals, and materials. So what you've got is like when you make a wind turbine, for example. Well, you've got bits of metal in that, but those metals have to come from somewhere. So you've got the industry sector will be used to calculate and create actual metal drawing from natural resources, and then they stitch it all together. And so it's actually it's not a perfect system, but it's actually much better than anything I've seen elsewhere. Mm-hmm. So here is iron and steel, for example. So you've got your natural resources there, raw materials extraction, materials to market, material making. You've got parts, assembly, manufacturing, distribution, and then you've got waste, recycling, and what have you. Stocks in society and irreversible diffusive losses. And so you've got that's how you see it, the symbol looks like there.
Right. Yeah.
Simple generic supply chain. So you've got hidden stores, resource stocks, known resource stocks, production, materials, resources market, manufacture, and so on, all the way out to ecosystems. And in all of this, you've got loss terms all the way through. So here's your industrial artifact materials. You've got plastics, wood, cement, and concrete. You've got things like production and recycling of electronics, car and aircraft and ships, processing of food. All sorts of things come out of this that I hadn't actually sort of considered. Here is the economy, environment, and energy. So you've got geothermal, wind power, hydropower, hydrocarbons, oil, gas, and coal, nuclear energy, uranium. Thorium is also considered in here. Harold is a supporter of the thorium MSR system. He's quietly working on that. Bioenergy, electrical power distribution and generation distribution, water use in energy production. So in environment, you've got pollution and toxicology, land use area, climate change and global impacts, biodiversity dynamics, natural fauna and land vegetation and insects even. Industrial and agricultural water use, freshwater drinking water, and urban water supply. and so on. So here's the economic module. Sorry, so you've got so you've got your raw stocks, renewable material stocks, energy, metals, materials, fossil fuels, phosphorus, and human work. So that's your flows going into industrial operation profits. But then you've got these loops that go around and around and around. So you've got speculation capital, social capital, agricultural capital, and what have you. Now, I haven't been through all of this, so I don't know the mechanics behind it, but I've seen this in action, and it's pretty awesome, hey?
Yeah.
So this is commodities and service prices, so simulated, fully dynamic models with, so these are the different kinds of markets. So you've got your free market. That's the one on the left. Free market, free actors, symmetric rules. The one in the middle is the oligarch market with, like a mafia, with unequal actors and biased rules. I would suggest the middle one is actually probably most useful describing our current circumstances.
Yes.
The one on the right is your command and control. This is your communism planned economy. And what was interesting is the feedback loops to actually make the case why democracy is actually needed for things to survive. And that comes down to the correction function when reality does not match up with plan. Right, so the economic feedback loop looks something like this. So you've got calculation R1, calculation R2, and calculation R3 in this model. So what was bizarre for me to watch was Harold was able to predict metal price. Market prices that are historical based on the model. It's not perfect, but that's actually a lot better than any other economic prediction I've seen. It starts with the physical realities of biophysical realities associated with systems, and it makes it to economics eventually. I didn't think this was possible. So here's health, food, population, and society. This is the population dynamics module. So the core module is based on biology, fertility, and mortality, feedbacks from healthcare, nutrition, and health, feedbacks from public education, women's rights and contraception, feedbacks from food and nutrition, and so on. The agriculture and food model is pretty simplistic at the moment, and the next World 8 will probably have a more sophisticated version, but at least there's something there. The front end of the population dynamics, this is birth. So you get your birth rate and everything associated with that. We've also got, how we actually sort of manage our society. You've even got a corruption term in there.
Nice.
And the back end or the dead end of the population, this is mortality, death. So all the things that go into death. So you've got life and death. And Tainter's principle, resources lead to more complexity and increasing permanent costs. Yes, so Harold had a crack at sort of modeling complexity as things go along.
Oh.
So this is the amount of resources, flow, value, and infrastructure debts. So the rate of energy supply, the rate of infrastructure in accumulation, and the rate of incurred cost of maintenance. So as things go up, you get waves of complexity, but within that you get this cumulative thing, and these things are overrun. So neither debts or interest can be paid in this section here. So we've actually got the vector collapse.
Oh, and that model is very similar to what John Peach was describing. You see, it's not symmetric.
Yeah.
It's more of a Seneca.
Yeah. John, I owe you a beer, incidentally, if we meet up sometime. All right. It's already started to happen. Peak fundamental resources, energy around 2020, minerals and metals about 2030, phosphorus 2010 to 2035, food between 2050 and 2060, workforce somewhere in the latter half of this century. Peak wealth production is 12 to 15 years later, 2035, and cost wealth 15 years later, cost overrunning wealth is 15 years after that. Now, Harold likes his history. I've had a few people argue with him about some of his details, but to me, he's pretty good. He modeled the Roman Empire. And in fact, Steve St. Angelo's done some similar work, actually. And it'll be interesting to see Steve's opinion on some of this, actually. All right, fuel max. maximum occurred in 350 AD. Grain followed after that. Metals followed after that. Land followed after that. So maximum resource outputs peaked in that sequence, and 15 years later it was maximum wealth. Cost outrunning wealth occurred 15 to 20 years later, and the Roman Empire empire collapsed soon after that. So he's actually modeling what's happening to us now in parallel. It's not the same thing, but history doesn't repeat, but it does rhyme, I believe, is the what he's talking about here. So that's some of the data he's assembled. This is all Harold's work. I'm merely presenting one of his presentations. All right, so here's some of his model outputs. The red is his model. All right, resource scarcity may limit photovoltaics. So a necessity to combine technologies. And so fossil fuels, oil, gas, coal, peat, uranium, thorium, geothermal, many biofuels, and so on. Technology-based energy to harvest photovoltaic and wind is what he looked at. And then renewable energy, hydropower, geothermal, and a few forest-based biofuels. Now, what he's done is he split things up into what's wanted, what's affordable, and what's available. So demand is your blue. That's the line one over the top. If we modified things, that's the dark green. Supply is the red. Now, that supply is made up a combination of mining and recycling. Let's say we get our act together with recycling. Let's say that actually happened. That's our actual supply. So we want the blue, but we get the red. Ouch. Right, that's lithium, and that's indium on the right-hand side. So supply and stock and so on. So here's germanium. So demand is the blue, dark green. The blue is the supply. Right, so around, it looks like 2045, something like that, we get a problem. And so he's actually modeled the price. I still don't understand how he does the price. But then again, he's actually producing results that are more sophisticated in outcome that seems to age much better than many of the other analysts I see. So the price, it was very expensive decades ago. It's crashed, but around 2045, the price is going to skyrocket, and that corresponds with that drop there. So germanium, not good. All right, so you went through a whole series of things. Then there was the question of what's actually sustainable. We keep talking about 2050. That's 25 years away, right? Sustainable for me means enough for everyone forever.
Right.
And the only true sustainable society I've come across is the Australian Aborigines. They were Stone Age, and they were in perfect harmony with their environment indefinitely. But anyway, Harold's actually sort of done a simulation out to 2400. So he's gone through each of the metals. Things like gallium is enough at 2100, scarce in 2200, and exhausted by 2400. So this is iron, manganese, chromium, and nickel, and that's copper, zinc, and lead. This is, I think these are inputs. So what he's actually modeled, he's got a low estimate. This is global sustainable population estimate. Right, so this is the population. So the low estimate is the white circles. The high estimate is the red triangle. So we're somewhere between those two. Right, and so, but the UN unbounded predicted population is the blue. According to World 3 is the 1972 limits to growth standard run. That's that one there, the green. Harold's World 7 FOF model is the black line.
Oh, wow.
Right. So, yeah, he's predicting.
Looks pretty good.
It's better than World 3 is what he's predicting, but it's not going to be what the UN thinks. All right, electric vehicles need resource management. So he didn't use my work. He came at this whole thing from an entirely different action. Charlie, I've actually sent you some of Harold's work where he's actually calculated the amount of energy it takes to produce a ton of metal for each of the metals, which is something that'd be very useful. So resource quality is declining and cost and effort go up in order to maintain supply. That's not rocket science. Okay, so he's actually sort of done some analysis similar to what John's done, but perhaps in a more simplistic fashion for a lot of the metals. So he's got extraction peak here, supply peak here, recycling percent and then for the metal. And so he's got peak extraction year 2012 for oil. Obviously, that's not correct. Right. So there's problems there. But he's got iron at 2052 for peak extraction, and peak supply is 2072 with a degree of recycling. That's iron ore. So he's gone through these calculations. Obviously, it's not perfect. So challenges. He said the number of challenges that pile up in the simulation. Yeah, holy smokes. Right. So now he's starting to talk about energy production, energy supply per person, and the UN business as usual impact and all that. This is probably a bit more useful for you. So extraction and production methods, say hydrocarbons. Is the energy source sustainable? No. Is the material use sustainable? Is it environmentally sustainable? Is production and its use socially sustainable? And then there's a totally sustainable. And then we've got, so uranium energy is no. Thorium energy is no, because the materials, you will burn through them eventually. Geothermal is yes by design if you design it properly. Hydropower, yes, if you design it properly. Biofuels, yes, if you design it properly.
Yep.
So Jorgen Manders, who wrote the 2052 book that was flashed up before, Harold took some of his suggestions and turned them into policies. Policy suggested, does it work? And so on. UN high population scenario, will it work? No.
No.
Help poor nations grow faster by rapid industrialization similar to Japan, Korea, and China. Will it work? Difficult. And so on. All right, so he's got the business as usual, the way we're operating now. Stocks in use is blue, and finite resources is red. I'm not quite sure what provision means. I think it's actually sort of what we're using. So, but if we get business as usual
like
plus
production.
recycling, yeah, could be. But I don't understand how they separate. Business as usual plus recycling plus resource reuse reduction. And the last one, business as usual, recycling, resource reduction, and enhanced resource use efficiency, as in if we actually got on with this and did it properly. Can we change things? So efficiency gains. Now, at the moment, the current economic model, an increase in resource efficiency will allow us to make more economic growth with more economic growth, make economic growth with smaller economic growth, and so on. The amount must be used. So what are we really trying to do when we're trying to create more growth? What's it for? And so concluding, everything's at stake, wealth creation's coupled to conversion and resources. So Harold's looking at a period over centuries as in what's the sustainability for humans at large? What's our long-range goal? So we need to act before resource limitations reduce our possibilities, and when we still have a minimum required capital value. Big change takes time, and we need to act at once. How we use the next 3 decades will be decisive. Don't squander the time we have left bickering. Okay, so I think that's it. And so that's more. So I'll stop there.
All right.
What's the Wailing Wall looking like? No questions. Oh, good. I answered everything. You're welcome.
well. Okay. Oh, I see Dusty has his hand up. Okay, go ahead, Dusty.
First question is, when can we get the guy who did that study on the pod? That's the first.
I can ask him if you like.
Yeah,
Harold's
sure.
close to retirement. He's one of these guys. He's independently wealthy. I think he's got like a controlling share in a precious metals mint in Norway. So he's rich as shit. But he's also world class in his work. I can ask him to come on. Let's see what he says.
Great, thanks. Glad to hear.
Second question is, how can a model like that be turned into a more consumable product for an everyday person? And then what actions are, would a second paper to go in line with that be? What are good actions to take?
Right. So at the moment, this is such a sophisticated piece of work. It requires a lot of thought and complexity and to keep things in context to make sure you're doing things correctly. So it requires, frankly, people who know what they're doing to even understand the results. To make it usable, so the average person would use it, you could probably use AI to... The model probably needs to go through more iterations to make it, harden it up, to make it to the point where you can have like an AI-driven interrogation of it. And then there's as a planning tool, what would you do with it? Well, that depends on where you are in the value chain. The answer, Dusty, that I think we're reaching towards, is it possible? Yes, it is. I believe it is. Harold thinks he's going to retire.
That's when things just get started. Yeah. All right. Oh, okay. I see. Roger.
Dan Gowan's got to leave soon. So Dan.
Okay, Dan. Okay. Yeah, Dan. Did you want to say something?
No, I didn't really have any. Well, maybe I do have something to kind of show everybody.
Yeah, right.
If you allow me to.
Okay, go ahead.
Let's see if I can get this to work quickly. No, entire screen. Window. Let's see here.
Oh,
Don't worry. I told him I'm not going to go lock UC up in the bar while we go to the museum.
Yeah.
They do what they want to do.
Do you see that? I'm sorry.
Yes. Yep. Indian power plants.
Yeah. So I'm sorry. So these are all the coal-fired power plants in Indiana that are on my list. And notice you can see I've got closure dates here. So this is the updated list. But this is sort of my challenge. And going down here, the bottom I've got here. These are the power plants I helped convert over to combined cycle, where we added a gas turbine to boil water to drive steam turbine. But it looks like probably 10 years from now, that probably won't be a good decision. And the whole reason why we converted those to combined cycle is because of the quality of coal and the cost of burning coal, and why it's becoming impractical. So anyway, I'll stop sharing it.
Okay. Cool. Yeah.
So that goes back to what my big project is trying to convert those power plants over to geothermal if I can. It might be a tall order to do, but if I can, and try to convince these guys into just exporting the coal to other people that can probably use it more than what Indiana does. So.
Yeah. So you were telling us earlier, Dan, about the running out, that the California shutting down is going to make a big effect. Can you explain that a little bit more?
So the Phillips 66 refinery, they've already started dismantling it as we speak. It started in the 1st of October. That's there in LA. And
Okay.
Valero has already made the decision to shut down the refinery up in Benicia. I think that's how you pronounce it. Benicia, California. And that represents 20% of California's gasoline, diesel, and jet fuel.
Okay.
And Chevron had a refinery fire there in LA about a month ago, but we haven't heard anything about when that's going to come back online. So, but the point being is, it's not a theory; it's a fact. All that's going to occur. The big impact will be, basically the start of driving season next spring, right? And then it will impact gasoline prices in California. So right now they're forecasting $8 to $9 gasoline.
Wow.
Yep.
Per gallon.
Per gallon.
Wow. Okay. All right. Okay, Ivor, did you have something on this?
Yes, I have it on Simon's, the recent new run of the world model, Harold Snurdrup. Okay, I checked out those, those three peaks that you showed. One, you can pay back both interest and principal. The middle one was you can pay the interest, but not the principal. And then on the third, sort of the last peak was neither debts nor interest can be paid. And I think we're somewhere around the middle hump, if not further along, because I know the United States, we can just barely pay the interest, but there's no way we're chewing down our that one there.
Yeah.
So that's kind of interesting, because that's kind of the end of almost all societies, right?
Harold did a simulation run that we Peter and I put it in the Hawaii report of how to actually what happened in Easter Island. He did a game theory simulation of what happened, and to me, it's pretty good. Right, and he's able to capture concepts like things on the screen. I've found we don't necessarily have to make things more complicated. It's not about complexity, it's getting the right things used correctly.
Mm-hmm.
And so we can actually pin and model the bottlenecks in the system. And I think Harold's been able to do that. I've seen other people do that as well. But that seems the key. And instead of like the broad brush shotgun approach, a more stylized, intelligent. Roger, you had your hand up for ages, mate. You're still alive.
Yes, still alive. Only two very, very quick things. One is Simon, just an excellent presentation. I really like the move from the 72 through to the World 7 and then the Earth 4 in the middle. That was just very, very good, very good. If you can get Harold Sverdrup to come and talk to us, that would be brilliant. And then just a footnote to all that, as you probably all know, but I'm not sure you do, IEA in Paris has, as Jean and others know, global conventional oil, global stress conventional oil as in decline from 2008. And we're all pretty sure that's essentially resource limited. You can get a little bit more, but conventional oil in decline. So we're already in a world where we're having to move to the tougher, more difficult oils, as Charlie has talked about for so long. Thank you, but an excellent presentation.
I'm standing on the shoulders of giants. This is actually not my work.
Right. Yeah, I was wondering if Harold could integrate, some of the work with John Peach and Jean Laherrère, like in terms of their model to update, the peak oil. And I don't know if he has a symmetric decline or what kind of curves he has.
So I've been showing Harold what I've been doing, and I've been showing him John's work and Art Berman's work and Gene's work for a while, and I think he likes it.
Okay, good.
It's a question of time. Like, how do we get all these things together?
Mm-hmm.
How do we put all these things together to? Yeah, I can ask him. Let's see what he says. Harold's notoriously difficult to get hold of.
Mm-hmm.
He's close to retirement. He's also subject to his challenges as well, like everyone else. And I think he's at the grumpy stage.
Oh, okay. That happens.
But if I ask him, let's see what he does. He might come along. And so, but he's world class.
Great.
You guys love him.
Awesome. I also have some more questions from the YouTube. Some of them from a little bit earlier. It says, the Listo says, thank you all. In the life sciences, there has been a known replication crisis for some time. Can that be said of this field? Are these model fitting errors still significant finding in that light? So I think he was talking about the earlier Earth for All model.
Right. So I think what I think they're basically asking there is what's happened with the Earth for All model? Was that an accident, or did they do it on purpose? Mm-hmm. And if it was an accident, how did it happen? it's hard to not come to the conclusion that they did it on purpose. They had to know what they were doing. I don't know. Like at some point they must have understood, and they decided to keep going. I don't know. I don't know the people who did that. I don't know why they did that. I do know their work has been used to great effect. Is it a flaw in the paradigm behind some of the social sciences? I don't think so, because this is a mathematics model. The mathematics systems game theory, this is a known way to operate. And they would have had to have disengaged standard practice. They didn't even balance things. Right? So the flaws there are mathematical. Social sciences are really hard to get hold of, and they're really hard to quantify. I don't know the answer. Let's just say.
Okay.
Yeah.
Cool. And a related, it says, I looked at Gaia Harrington's 2004 revision of the World 3 report. Did Gaia or the Club of Rome have something to do with the faulty work that Michaux presented?
Unknown.
Okay, unknown. Okay.
I suspect, but we're actually in a territory. I've actually just presented a very challenging review of someone else's work. Like I basically said, someone has messed up badly.
Right.
So
the answer is, this is Charles Hall, who knows something about this, and the answer is no.
Oh, okay. Okay, thank you. Thank you for that clarification.
I'd like to say something too, please, very quickly.
Go ahead.
I need reviewers. Speaking as an editor, I need good reviewers, fair reviewers, but very knowledgeable reviewers. If you are one of those people, please send me your email with very briefly your qualifications. Getting this reviewed is going to be tough.
Okay, cool. Thank you. John?
Yeah, quick question, Simon. All these models, the world models,
yeah,
it seems like they are all sort of based on economics.
Yep.
I always thought of the economics as sort of a proxy for energy, right? I wonder how much do you think it would change if you looked at it from an energy point of view rather than an economics point of view?
That's World 7. In fact, that's Harold's approach. I think, Charlie, Harold's a fan of yours, because he said a few things that suggest he's actually read your work. The original work for all of these simulations is indeed economics based. And if you like, get hold of Steve Keen, and he can destroy the neoclassical paradigm of how all that works. You can set fire to it and burn it to the ground. But when Harold actually sort of looked at this, my understanding is that he really didn't like what he was seeing. And he was saying the world is actually sort of based on principles of natural reality. And I think he was developing World 7. I don't know if he started with energy, but he started in a loop of the natural world.
I was looking for that.
He was starting in the natural world first, and
I'd still like to do it. Okay.
Oh, I think Charlie might have forgotten to mute himself. Hold on.
Yeah. So he started in the natural world first, and he went round and round in a few loops, and the economics was an outcome. I believe it was the natural world first, and it was money second. I think that's how he did it. I know that's what he wants to do. And his next evolution is going to be a more sophisticated version of that if he gets around to it.
Right. That's kind of what I've been thinking, is that it really should have been a natural world model first, and then based on it. But the original team at MIT was in the economics department, which I think is why they went that way, or the business school, Sloan Business School. So that's probably the explanation for why they started from that one. So it's just what they were thinking about.
Neoclassical economics has been the very heart and paradigm. They occupied the position of, we've got the rules of reality. for the last 50 years. And
Right.
it's been a con, an absolute bloody con.
Yeah, we got to displace conventional economics with biophysical economics and then start all over again.
Basically.
So,
Yeah.
Charlie, I actually want to take some of your work and turn it in and use it. I actually want to take my resource balanced economy and evolve it into a biophysics economic system. And I was
Good.
going to actually come and talk to you about it at some point. And
Good, yeah, I'm always available.
And if you've got the minerals for it, pun intended, we could write a book together.
Oh, I'm 82. I'm exhausted. I've been doing this for 5 decades, and
So you're
have had absolutely no progress with the economists.
So we shoot them all and leapfrog the bastards. Look, I talk to world-class guys all the time, and they all think they're going to retire. You think you're going to retire? We won't let you.
Oh, I haven't reached. I mean, I retired 15 years ago, but I'm, still publishing as much as ever.
The number of people who are after me,
And my voice is failing me today. I don't know why.
Yeah. Anyway, I'll come after you later.
Okay.
Yeah, sure, great.
And I could possibly take part of your review team as well if you would. I'm actually going to scale back my professional activities and start working on my personal stuff a little bit more. So I can help you, Charlie, a little bit more than I have been.
I recommend fishing.
What about drinking?
No, I do not recommend. It kills brain cells.
Fishing.
Yes, fishing's much better.
Fishing. That's what sustained my sanity.
But fishing's not about the fish.
Well, it's about being in nature.
Yes, it's about being in nature. Okay, Dusty, you have a question?
My question is kind of about like what Charlie said about decades. It seems like there was an interest in this type of topic in the 70s, and then what the oil drum stuff was like late 90s to early 2000s. It feels like we're at another kind of resurgence of this topic a little bit. There seems like there's some people, but how can we, I feel like maybe as a group, we should try to figure out a way of capitalizing on this. I know I was joking about doing some videos with Simon doing a voiceover, but I wasn't actually joking. So, there's only like a couple YouTubers that I can think of, for example, Nate Hoggins and on the left and Chris Martinson on the right that seem to ever really talk about this. Maybe there's a few others, but there's very few. So
both of them seem to be trapped in a paradigm. They both operate in a window and they're reluctant to leave that window. I've also noticed that when people put together a message, they stay in that message over years, and it's hard for them to evolve out of that. I've come to the conclusion that instead of actually trying
path in the woods.
Yeah, I suppose. But I've come to the conclusion that trying to actually sort of find a solution for 8 billion people and try and convince people, and that's a thankless task. And the very people who you are trying to help will take the time to fight you and will destroy you if they can. So my current plan is to get together a group of like-minded people, a small group of like-minded people, and then do something remarkable. Now, once we do whatever that is, we tell people what we're doing and we lead by example. And we don't wait for the approval or the admiration of others. We just keep moving.
And I agree with that, but I think you still need some form of a leveling up of communication and et cetera, to find those small group of people. Mm-hmm.
But instead of actually asking for permission to live, it's kick the door down, make it happen, leave the building, burn it down. While you communicate.
Well, I'm going to try to do it at a municipal county level over here, but we'll see. It's I still have to wait another 7-8 months before the election. Even the campaigning starts. Okay, go ahead. I
remember this being a very pretty path.
Yeah, I had one little point to make about economics.
Mm-hmm.
And you said like the last 50 years have been kind of ridiculous, right, for economics. Well, the thing is, that's about the time that we let go of the whole world let go of anything beyond fiat currency. So we've been on fiat currency for 55 years or so now. So the reality that imposed on the world economy, that was almost like a physical limit, and it's been gone for 55 years in most of the world. Because there were silver coins before that, and there was things you were based on something. And we haven't had no economy has been, the entire world economy has been based on just nonsense since then, maybe petrodollar or something, but who knows what. Just pointing that out.
Been based on energy always.
Yes, but I'm saying, there was,
and energy has increased, so GDP, etc., has increased.
Yes, yeah.
Okay, well, let's try to round it up within the next 5 minutes. Okay, Dusty.
Five
So
more
I
minutes.
guess long story short, what I was trying to say to you guys is, if I work best on a team, so I enjoy being able to be here. Thank you to everyone. And then if anyone does want to start to organize a little more, even just simply maybe doing a YouTube channel that tries to turn some of these things into some more communication to reach out to more people, maybe start a Discord, somewhere where people can land, somewhere where if people are hearing about this and interested, that they can find a place to land. I'd be willing to work together to try to make that happen.
Well, we do have the Peak Oil Chat group on Facebook. Right
And
now.
Dusty, I have a lot of videos for you. Charles Holt saying that.
Yeah.
Or for anybody who wants them. Lots.
Great. All right. Okay. On the agenda still next time, Jean Laherrère, he did make some updated graphs, and he's 90-something years old, and so he wasn't able to stay for the whole thing. But hopefully we'll have a presentation from him next time. And then I know John Peach, you also had another presentation you wanted to give. I don't know the timing on that.
Doesn't have to be next time.
It doesn't have to be next time.
Yeah.
Okay.
Sometime.
Okay. So we'll just on a kind of an empty slot. And then also I wanted to kind of present some derivatives of both John Peach's and Jean Laherrère's work. So that'll be first week of December. Okay. Any closing remarks, John or Simon? John, how about you first, and then Simon will close.
It's not a very long trail.
So what?
I remember it longer.
Oh, okay. All right.
Let's go down there.
Okay. I'm just.
Just Roger, I'd really appreciate the data that you have, if you don't mind sending it.
We're muted, Andrii.
Oh, sorry. Thanks.
Okay.
I will send it to Andrii and then forward it. Ask him to forward. Thanks. Yeah, happy to do so.
Okay. Awesome. Okay. Thanks. Okay, Simon. Okay, what would you like to close with?
I would probably close with the understanding that there is a widespread awakening that's happening all around us. People are starting to get it. Things that were impossible to understand years ago are now digestible. And I see that as a temporal marker of where we're at. And once certain things become common knowledge, I think things are going to move pretty quickly, especially to the next step. Now, we've been operating for years in a way where we do good work, but we're ignored. Imagine, if you will, every one of us got paid 6 figures to do our work and then present it to sitting decision makers in governments and corporations. Imagine, if you will, if that actually sort of was actioned and we didn't have to beg for scraps and sing for our supper anymore. What I'm suggesting is not only the people on this call, but the people listening to this podcast, You're in that group. So consider what's coming for the future if we are successful in getting our message into the common space. And that might be happening sooner than you think. That's what I would close with.
Okay, thank you. And so I know there was a YouTube person that also is voting for the Discord, so Dusty and I will talk about that. Otherwise, greetings. I mean, as we found you, we leave you in the infinite love and infinite peace of the infinite creator within you. Go forth rejoicing in that infinite power and infinite peace all around you and within you, my friends. I don't know. Okay, ending the stream.
Thank you.
Okay, the stream